Hello everybody, my name is Herman Baer and I'm working at Oracle in the database product management team. I am having the pleasure to talk with you for the next 25 to 30 minutes about the top 5 things not to miss with Oracle partitioning. Whether you are already using Oracle partitioning or whether you're planning to use Oracle partitioning, I'm hoping there is some interesting information for you in the following slides. Partition, to divide something into parts. Well, this is exactly what Oracle partitioning is doing for you for your tables or indexes. Oracle partitioning enables you to take one logical table and to divide it into many physical independent partitions where each partition contains a subset of the table. As you can see in this example, there is a table sales, one logical object that the application or the user is working with. And under the covers, this logical table is represented as many partitions, each partition containing a subset of the data, representing 1 month of the data. With such a setup where you have many independent partitions containing a subset of the data, you all of a sudden are enabled to manage these partitions individually based on the importance of the data and the life cycle of the data. As you can see in this slide, while we have the end user working against your table sales, an administrator could move the partition for the January data under the covers, compress the data, and change the state of this data into immutable. It's also that partitioning not only subdivides your table into individual partitions, it also stores the information, the metadata about what data is contained in which partition, transparently in the database. So without changing your application, if your end user all of a sudden is only accessing a subset of the data, like you can see on this slide, the data for January, the Oracle database transparently eliminates all the partitions from the query that do not contain any data that is needed to satisfy the operation. So in a nutshell, on a high level, Oracle partitioning brings powerful functionality to you and your application to logically divide objects into smaller independent pieces. It is also a key requirement for especially large databases that are needing high performance and high availability by making one large logical object looking very small for query processing and query maintenance. And since the partitions are independent and do not have any kind of constraints or strings attached to the fact that the layout might represent something that you need for data processing, the setup of Oracle partitioning is solely driven by business requirements. Now let's look into the top 5 things that we consider important for you not to miss or to ignore. The first one, to partition or not to partition. Just because you can does not mean that you have to. Apply functionality everywhere. So it is important just to look at your objects, at your environment, to see whether you can take benefit of partitioning or whether you're applying the wrong technology for the problem. Assuming that partitioning brings benefits to you, it is important to quickly recap what to consider to choose your partitioning correctly and to take the best from Oracle partitioning for your application. Another topic is the importance of data maintenance. This is a topic very often overlooked in the past, but becoming more and more important for today's mission-critical large systems. Object store integration enables you to bridge the database to the world of the data lakes of the 21st century. This is true for both databases in the cloud as well as for on-premises. And last but not least, one important thing for you not to miss is simply to know at any point in time what's out there with Oracle Partitioning. Now let's look into these top 5 things in more detail. To partition or not to partition? This is the question. To look into the decision of to partition or not to partition, let's make a quick theoretical mental exercise. Imagine you have a 100 terabyte table and you have equal data distribution across the partitions. With 1 million partitions, which is the maximum that you can have in an Oracle database, each partition would be 100 megabyte in size. If the same table would be only 10 terabyte in size, with 1 million partitions, each partition would be 10 megabyte in size. And if your table would be 1 terabyte in size, you end up with a partition size of 1 megabyte. Now, the question for you to ask yourself is, how fast is your I/O subsystem? How long does it take your system to read 1 megabyte? And how much can you actually read in 1 second? Just to give you a data point here, an Exadata machine, a full table scan rate is between tens to hundreds of gigabyte per second. Now the obvious question begs, how do I take this information to decide to partition or not to partition? Well, the driving factors for you to make that decisions are your use case, the planned number of partitions that you would get, and the average size of your partitions. First and foremost, from a use case perspective, whatever partition granularity you pick must provide you business benefits. We are not partitioning just because we can. For example, if your business application is only working with data on a daily base, choosing a partition granularity that would go down to an hourly base does not provide you any additional business benefits. Now, looking at your application, your use case, and the size of your objects, the question begs, okay, what would be the minimal and the maximal size of your partition? Minimal partition size, in general, should not be scannable in sub-seconds. The maximal partition size, however, on the other side, should be scannable in a tolerable time for you. Average numbers that we hear from customers here are probably in the range of 10 to 30 seconds, probably up to a minute. In general, there is nothing wrong about single or double-digit gigabyte partitions on normal systems, although your mileage will vary. The most important thing here is not to become too small. Because more partitions is not always better. They mean additional work and storage in your database system. Every partition represents metadata in the dictionary. For storing the information about the additional partitions, the additional segments, potentially the local index segments that go hand in hand with your table partitions. And since this information is actually necessary to process the data in these tables, every partition increases the metadata footprint in the SGA. Larger number of partitions can also impact the performance when working with catalog views. So please bear in mind, the minimum size is very important, not to go too low. The maximum size, the mileage varies depending on what is tolerable for you for single partition processing and what is the business use case for your application. Okay, assuming that we have identified that partitioning brings us benefits, which is the point, you wouldn't listen to me anymore if that was the case. Let's now have a closer look. What are the questions that I have to ask myself to choose the partitioning strategy correctly? It's actually not that hard to identify the core partitioning setup for your application. The things what you have to do is you have to think about your data, and you have to think about how the data is being used by your application, by your end users, and how does the life cycle of your data look like within the application. So there's 3 fundamental questions that you have to ask yourself to understand your data and your application. How is your data shaped and inserted into the system? How is the data in your system accessed by your applications and your end users? And how is the data maintained in your system? From a loading perspective, from a data maintenance perspective, from a data archival perspective. Let's step now through these 3 questions in a little bit more detail. To answer the question of how is your data shaped and inserted into the system, look at how your data looks like. Are there any key attributes within your data that are driving the business? Is there a time attribute, for example? Does your data consist of a location information like geography, like cities? Is there any tenant or business user information that is relevant for your system? If you have identified how your data roughly looks like from a data shape, from a data correlation perspective, how do these classification attributes look like? For example, do we have ranges within these attributes? For example, very common, you see the case that when you have some time attribute driving the data, it is in ranges. Is it an unrelated list of values like the geography? Or is it just lots of them, like the product key, where you have a catalog of tens or hundreds of thousands of products? The shape of the data very often, or almost goes hand in hand with how your data is accessed in your system. But now it is important to understand not only which attributes are driving the access of the data, but how does it look like when these attributes are being used? Is it a quote-unquote always full working with the data, where you potentially apply some machine learning algorithms to large sets of your overall data? Or is your data accessed with common filter predicates? Assuming you have some kind of time attribute in your data, it's not uncommon to see that you have filters for a lot of queries, a lot of working with the data that shares commonality, like you go after last month, the last day, the last quarter. Or does your system look like in a way that you're mostly driven by index access, where it is important for you to find the information, the small number of sales that was done by an individual customer on an individual day? If you don't know how your business use case, how your business end users are working with the data, how the data is accessed, this is a red flag, and you should go back to the drawing board with the business to identify how the system is going to be used by the end user or application. To answer the question, how is data maintained in your system, it is important to understand whether you have some moving windows of active data. This is true for both the insertion of data as well as the potential retirement of data. For the retirement of data, it is important to understand, are there any kind of legal requirements? How long do I have to keep the data around? Is it 5 years, 7 years, or is it something which is more quote unquote forever? If you don't know this yet, this is an equally red flag, which requires you to go back to the business, to the application, to get an understanding of how does the system behave from a lifecycle management perspective for the insertion and the removal and archival of data. If you have answers to these three questions, you have a very good understanding how to choose the best possible partitioning strategy and how to potentially apply the benefits that partitioning brings to the table for your end users and application. Whether this is on the query and the DML speedup side by actually partition along the common filter criteria that you see in the way of how end users are working with the data to take advantage of partition elimination. Whether this is, to leverage partition-wise joins for the large-scale full data set processing for machine learning and deeper analytics, or whether this is more on the highly concurrent side to alleviate index contention points. Understanding the life cycle of the data gives you a very good feeling for how to potentially leverage partitioning for data storage optimizations to start to repeatedly compress and move colder data into different storage tiers to increase the compression ratio for them, or to keep the hottest data in memory. Remember, we're talking about one single logical table and about the data maintenance of individual partitions. The same is true when we talk about the data maintenance from a perspective of whether we choose DDL over DML. A lot of the time when it comes specifically for purging of data, it is very often easy to replace DML operations with DDL, saving tons of resources for processing of this data maintenance operation. Let's now have a quick look into more of the details of data maintenance. Data maintenance is becoming more and more important for systems due to the ever-increasing mission criticality, as well as to the ever-increasing size of the systems. As the Greek philosopher Heraclitus once said, change is the only constant. Data is changing all the time. You're inserting new data, you're updating data, you're deleting data from your system. Also, the importance of specific data within your application, within your system, is changing all the time. For example, if your most important purpose of your system is sales analysis, and the driving factor is what is the sales of last quarter, then the data set that I'm dealing with today is a different one than I'm dealing in the next quarter. And it's a different one than the data I dealt with last quarter. Last but not least, business requirements are changing all the time. Whether this is by all of a sudden trying to analyze the data along a different dimension, along a different attribute, or whether this is while the business requirements have changed and all of a sudden you're not interested in analyzing your sales data on a quarterly base, but potentially on a monthly or a daily base. Partitioning offers a full set of functionality to help you cope with the ever-changing nature of your data and your business requirements very efficiently and cost-effective. Partition maintenance operations, the functionality to manage individual or multiple partitions independent of each other, enables a lot of the data lifecycle management operations. You can move individual partitions to change its location and storage attributes. For example, from a non-compressed partition to a highly compressed partition for archival purpose. Merge partition enables you that many partitions can become one. For example, if you enter the next fiscal year, you could decide to merge monthly partitions into quarterly buckets, or to split partition. One partition can become many. If you have, for the example that I mentioned before, you're changing your requirement going from a quarterly analysis to a monthly or daily partition analysis. You can simply split a previous quarter partition into the individual days of that quarter, or to quote unquote remove older partitions from your system. This can be done in two ways. You could either drop old partitions, meaning completely remove the data from the system, or exchange partitions with empty standalone tables, which only logically removes the data from your system while preserving the data still in the system. Table conversion operations enable you to address the ever-changing business requirements. You can modify non-partition tables to become partition table if the data volume reaches the threshold where partitioning makes sense, or the business use case requires you to partition a table. You can change the partitioning scheme of an existing partition table to address either finer granularities or new business requirements. And all these operations, whether this is a partition maintenance operation or a repartitioning of a table, all of these operations can be done in a fully online manner and support index maintenance as part of these partition maintenance operations. Now, having talked about partition maintenance operations and the capability to do those online, just one word of caution, or shall I call it common sense? While all online operations sustain application transparency and actually have no impact on the business, well, it's a minimal impact because you need additional resources to do that. This should not stop you from thinking about when to do these operations, because the cost of an online operations increases with the concurrency of DML operations. DML operations have to be tracked internally recursively to being applied to the partitions that you're working on with the partition maintenance operations. Consequently, the more concurrent DML operations are happening, the larger this journaling will become, and the longer it will take to apply the journal to the table as part of the partition maintenance operation. It's also that concurrent DML operations have an impact on the compression efficiency. The best compression ratio is achieved when you have minimal DML operations. Let's now switch gears a little bit and talk about new and exciting functionality that was first introduced in Oracle Autonomous Database and then backported to Oracle 19c and above. The integration of object stores with the database. First, a quick rehash of what are object storage. Object stores enable you to store large volumes of data in a highly scalable, reliable, and cost-effective manner. Object stores can provide you public or private access, and for the private access, the authentication and authorization is done through the cloud platform. An object store is organized as buckets of stuff. A bucket is a top-level container with a flat hierarchy. It's not a classical file system, although some object stores start to introduce file system-like capabilities. The stuff that you store in these buckets are objects. Objects consist of data and metadata and are unstructured data in any way, shape, or form. The access of object stores is normally done through user interfaces, CLIs, or programmatically through REST and SDKs. So now, what does this mean, right? We have object stores. What does it mean for the database? Data in object stores can transparently be accessed from the database. whether this is an Oracle Object Store, Amazon S3, Azure, or Amazon S3 compatible object stores. The benefits of object stores multiply when you combine those with partitioning, because all the benefits that we talked about with partitioning before, to only touch the data necessary for satisfying a query, as well as to manage and store the data where most appropriate, are all of a sudden attributes that you can combine with partitioning in object stores. So how does object store integration look like? Well, the most simple case is you want to actually load data that is stored in the object store. The database enables you to just access the object store and load data as is. At this point in time, the benefit of partitioning isn't really in place. But what does it mean to actually access this data instead of loading it into the database for processing? If you combine the power of partitioning and the capability of storing data in object store, you can define a partitioned external table on top of multiple files residing in the object store. And all of a sudden, as we talked about it before, if you only access a subset of the data that is stored in the table, the partitioning metadata will help us to eliminate all the data that is not necessary to being touched for processing and satisfying the end user or application query. Now, if we're looking at Oracle 19c and its capabilities of hybrid partition tables, we can now go a step further and even logically combine data that is stored in the object store and data that is stored inside the Oracle database, and combine them to one logical object that the application is working with. So you get the power of leveraging the object store as a transparent additional storage tier for specifically older data or for the newest data hot off the press that was just landed in the object store and you want to touch it for immediate processing. Okay, tip number 5, knowing what's available. This is, for many people, common sense, but for people that work longer with partitioning, just like I am doing, sometimes it is important just to reflect what partitioning brings to the table and what was enhanced over the years. Partitioning is around for almost 30 years in the Oracle database. It was introduced with Oracle 8.0, and over all the releases, there was a lot of functionality was added to the system. Now, if you happened to have developed an application back in the last century, potentially based on Oracle 9i, 10G, you might have not, well, obviously, you have not taken advantage of any functionality that was introduced afterwards in newer releases. So please do me a favor and check in from time to time, at least, whenever we get to a new major release, to see what was added to Oracle partitioning in terms of enhanced functionality, to see what's there for you to take advantage of, to make your system faster, more efficient, and more reliable. Let's recap the top 5 things that we should not miss or ignore. To partition or not to partition. Remember, just because you can is never a good argument. Look at the data volumes, your business use case, and what partitioning potentially can bring to the table. This ties into think about your data and your application to decide how to partition correctly. Don't focus on performance only. Don't forget the benefits of data maintenance. because data maintenance can impact your performance and streamline your lifecycle management of data significantly. Little changes can bring a lot of benefits. For newer applications or for evolving existing applications to take advantage of the data lake of the 21st century, think about integrating with object stores. Fuse on premises with the cloud. And check in now and then, please, to see what's available. Don't get stuck in the past. Just because something was great to develop in Oracle 11 does not mean that this is the best possible architecture or taking advantage of partitioning in today's world. For further information, here's a couple of pointers for you to read more about Oracle partitioning in the Oracle database. Also, if you haven't had the chance to actually try out Oracle, or specifically Oracle partitioning, sign up for the Oracle Cloud free tier. There's an always free account. It gives you an Oracle Autonomous Database that you can have forever to actually experience the benefits of partitioning yourself. At this point in time, I would like to thank you for listening to me. And if you have any further questions, please do not hesitate to get in touch with me. Thank you.